Hello everyone. This video tutorial is about 2D beam analysis in Abaqus. So this is an overhanging beam with uniformly distributed load, uniformly varying load, and point load. It has two supports. One is a pin support there and the roller support. So step by step, I'm going to solve this problem in Abaqus 2020 version. So that is Abaqus 2020 version. So the steps which you need to follow the steps are first is to model, then analysis, and then results. So in modeling, so these are further steps, so which modules you have to use. But before that, you need to make sure that you are using right set of units. So you can use either Newton meter Pascal or you can use Newton millimeter megapascal or Newton per millimeter squared. Then the next one you need to set work directory where you want to save all your model and outputs. So I'm going to save in chapter 3, and for that one you need to go to Abaqus file, set work directory, and here you can simply link your folder. So that is where you want to save your all data. Okay. Now you need to go to part module and create part there. Part is a line beam which can be 2D beam. So its total length is 9.5 is the total length. So you can create that beam in 4 segments. But in this video, I'm going to tell you that if you are going to create a beam of total 9.5 length, and then how you can partition it. So here you can go to part module here, or you have part here. So in the model part, so you can either click here. So it is beam 2D deformable wire, and approximate size is 2 times the maximum dimension, so which is 9.5. So I'm going to set it as 20. Continue, and then here is the grid. So using this one connected lines, so I am going to draw a line of 9.5 meter length. So that is a single line, and then I'll create partition. Or otherwise, you can go like the first one here, 2, 2, 3. So 2, you can go 2, then 2, then it is 7, like that way. So you have two options for that. So either you can draw a beam like this way, or you can draw a single line. But in my previous videos, I draw the beam in segments, but here, the new one, I'm going to teach you that how to create a single beam and then create partition of it. So once you have drawn that, so then done, and you can see that here you have created a part as part 1, or here you have created that 2D deformable part. Next one, you have to, in property module, you need to uh, create material, create profile, create section, and then assign beam orientation. So the material here is steel with modulus of elasticity 200 gigapascal, Poisson's ratio zero point 0.3, and then here I second moment of area from 1 to 4 length is 600 into 10 to the power minus 6, and then from 3 to 5 it is 300 into 10 to the power minus 6. although in practical beam is not possible, but it is just for the learning purpose. Two sections with two different moment of area are presented here. So I have assumed it's cross section, and then with 600, 600 in 10 to the power minus 6. So side of section is 291.3 millimeter, and for the second one it is 245 millimeter, and it goes to 0.245 meter. Because I am using the first set of the equations, Newton meter Pascal, so I have converted that, so it will be 200 into 10 to the power 9 Pascal, and all other units are in meters. So this beam is problem 3.2 of chapter 3 of beam elements from the book Introduction to Finite Element Analysis using MATLAB and Abaqus. So that is problem 3.2, and this is the beam which I am going to solve in Abaqus. So now in property module, create material which is steel, and you have here general density, and then in mechanical elasticity and elastic. So it is 200 gigapascal, 200 e raised per 9, and zero point 0.3. So that is the material. You have created material. Here you can see that this material steel is being created. So the next one is you need to create section, create profile. So you have here two uh, second moment of area. So you need to create two profiles there. So that is a profile. So profile one. So you can go like beam profile one. So beam profile one, and it is rectangular. Continue. So here you are going. Here you need to put those that value of 0.2913. So that A and B both sides are 0.2913, and then you need to create another one. So that is beam profile 2, and beam profile 2 rectangular. Continue. And for the second one is 0.2450. So 0.2450 I have entered. And now in the section, in the profiles, you can see I have beam profile 1 and beam profile 2. And the next step is you need to go to create section. So because you have two sections here in this problem, so you need to create two sections. So here in the property module again, so here create section. So beam section 1 and beam section 2, or you can leave that name as it is. So beam section 1 is beam, then beam, type continue, and profile name here you are going to give it beam profile 1, and material is steel. So okay, and you will create another one. So beam section 2, then beam, and for that one you need to give it profile to the material because you have created only one material. So then you have here, you can see there are two beam section 1 and beam section 2 profiles, and here you can see that beam section 1 and beam section 2. So the next one is you need to assign section. Next is you need to assign section. So here is a sign section in the property module. Here is a sign section, and it says that select the region to be assigned as a section. So I have selected that whole region. Done. Sorry, because you have here you have two sections. One is from 0 to 4, 0 to 4 is section 1, and then 4 to 9.5 is section 2. And for that purpose, if I try to assign a section to it, so what is going to happen here? So it is taking at a single beam. So because I have created that as a single part, so I need to create partition before assigning it section. Okay, so this is a new part which is not in my previous videos. So for partition, you need to go part and then you create partition. So here you go part and then you create partition, or otherwise you need to go tools and then you create partition, and it says that partition edge and specify parameter by location. Okay, so our partition face, it's a use. So these are partition. So you can go tool, partition, partition edge, specify parameter by location, or enter parameter. It says individually. So done, and then so it says select a point on the edge. So the problem here is, so partition edge, specify parameter by location. So you can select any location, but these are random. So we can create partition, but uh, we're not sure that which point is it. So for that purpose, you need to create datum point. So tools, and here datum, create a datum point by entering coordinates. Or otherwise you can go here, and you create coordinate. So it is first at 2, then at 4, then at 7. So you have created there three datum points. Then I'll go there, and then it's a pick a location on an edge. So this one, where you've created partition, then here. So here you choose this one, partition edge, select midpoint or a datum point. So I have already created that, so it is going to create a partition there, and then this point, create partition, and then that point here. So at that point, it has created partition. So you can see that in part features. So that is a datum point 1, datum point 2, datum point 3, partition edge 1, partition edge 2, and then partition edge 3. I'm repeating the process for more clarity. So you can go here, tool, partition, and partition edge, select a midpoint or datum point, and otherwise you can go here. So that one is partition edge, select midpoint or datum point. So it says select here. So it says select a point on the edge. So that is because it is just one section. So this one, create partition. It says select an edge, select an edge to partition. So then first I need to select that and select a point on the edge. So that is a point on the edge. Create partition and then select an edge for partition. This one, and then that is the edge. So create partition. So here now you have created partitions uh, on the beam. So now this is property. You need to assign section, and For assigning section, I'll go to the property module, and in property module, I'll here assign section. It's a select the region to be assigned a section. So I'll select these two first, done, and then this is the beam section 1, and then the next one I select, done, and then it is beam section 2, okay, so done. And once I have created that, then the next step is assign beam orientations. So here in the property module, you have this one, assign beam orientation. So select a region to be assigned a beam section orientation. So that is being selected, done. And then the same one, you need to press enter and then OK. So then beam orientation has been defined. Okay, so now to make sure that uh, like the sections are appropriate, you need to go to part module, and then you need to go view, and then part display options. In part general, render beam profile, so apply. So here you can see that because in the problem from 1 to 4, it's second moment of area is 600 and the next one is 300, and you can see, and then from here you can see that first section is like it has less cross-sectional area, and the sorry, first has more and the second one has less cross-sectional area. So this is to make sure that you have created appropriate profile and then you have assigned it. Okay, so you apply that one, and then so this is now part. So you have assigned beam orientation. The next one, you need to go mesh module. You need to seed mesh part and assign element type. So I'll go into mesh module, and here it says that the first one, seed edge, and select the region to be assigned local seed. So done. So you have two options, by size or by number. I'll go by size and I'll set its size as 0.5 meter. So that is 0.5 meter. Next one is here. So that is done. The next is you need to mesh part. So okay to mesh part. Yes. So now it is being meshed. And then here assign element type. So select region to be assigned element types. So I have selected all that region. So done. And then standard linear, and in the family it is beam. So it will be a B to 1, a two node linear beam in plane. So I select OK. So then it's done. Okay. So now you have created mesh. The next you need to go to the assembly module, and then you need to create instance. So parts part 1, so I say okay, so now assembly has been created. So the next one is you need to go to step module, and you need to create step. So in step module, here step, so create step, step, initial, general, and static. So I'll say that static load. So static journal here. So the name is static load, and leave all that as it is. So in the next one, you need to go load module and you need to create load. So on this beam, three loads are being applied. One is the concentrated load or point load at 2 meter. Then from 4 to 7 meter is a uniformly distributed load. And then 7 to 9.5 is uniformly varying load. So at 2 meter, so here I'll go to load module, here create load, and load one is, I'll say it as point load, and it's a static load which I have created. Concentrated force continue. At this point, I need to apply 20 kilonewton. So that is minus 20 minus 20 E3. So that load is being created. So the next one, I need to create load, and that is UDL is a static load, and then it is line load. Continue, and then it says that select the bodies for the load. So that part done, and then it is uniform, and it is minus 5 kilonewton E3. So that load is being created. So the next one is a little bit tricky, how to create UDL. So for UDL, you need to create equation of UDL in global coordinates. So you need to put here at node 1 as origin, and then you need to go forward, and then you need to develop equation for this UDL. So I have created here, you can see that for this point, its coordinates are on x-axis, which is the uh, beam length, it is 7, and the load at that point is 5,000. And then at last point, at the edge, its x coordinate is 9.5 and the load is 0. So I'll find equation of that. So first, the gradient is minus 2000, and then using any point, so I can create its equation. I can write its equation, and the equation is minus 2000x plus 19,000. And remember that here we are using global coordinate of length to create that equation. So for UDL, you need to first write an equation which is minus 2000x plus 19,000. And now I'll go there, here, create load, and it is UVL, uniformly varying load, static load, and it's a line load. Now I'll select this part to apply UVL. So done, and distribution is not uniform. So what you need to do for the distribution, because the system is global, I have created that with the global system. So here you will go user defined, and then you need to write its equation, create analytical field, and analytical field is UVL. Again, its equation, UVL equation you need to write, continue, and the equation was minus 2000 into with the static x minus 2000x plus 19,000. Minus 2000x plus 19,000 is the equation. Minus 2000x plus 19,000 is the equation of that UDL line. So it is UVL equation. So once you have entered that, press OK. And now again, distribution is now user defined. And in that user defined, I have that UVL equation. And UVL equation is already there. So I'll just put 1 times the UVL equation. So let's say 1 times the UVL equation, it's okay. And you can see that it is going upward. So I'll go there, and then UVL, I'll edit it, and it will be minus 1. Okay. So now you have created all that loads. Once you have created the loads, the next one is you need to create boundary conditions in the load module. And then the boundary condition at 1 is a pin support, and at 4 it is sorry, at 0 meter it is pin support, at 7 meter it is a roller support. So uh, in the load module, here you will have create boundary condition. So this, the first one is pin, and then step is initial displacement rotation, continue. It says select the region for the boundary condition, and that is the first one. Point selected, done, and then U1 and U2 are 0 there. So next boundary condition is roller, and that is initial, category mechanical, and displacement rotation. And here you have roller sport, and then so I have selected that and done, and thus U2 is restrained. So now you can see that here a boundary condition is being created, and then here a boundary condition is being created. So all that things you can have here like as loads. So point load, if I, so that is point load highlighted, UDL highlighted, UVL highlighted. Then in the boundary condition, pin sport is highlighted, and then the roller sport is highlighted. And with all that, its first part is done, in which you model, and then so whole model is being done. The next is you need to perform analysis, and for that you need to go job module and create job. So now once all done, I'll go to job module, and here is create job. Okay, so before that I rename that model as problem 3.1. Okay, and then here to create job, and the name of job is problem sorry, it's a 3.2, sorry. So it is problem 3.2. Continue and leave that everything as it is. So now you can see here you have created a job 3.2. Then you can perform data check, and data check submitted, data check running, and then data check completed. So when it's completed with without error, it means everything is okay. Then I'll submit it and okay to overwrite, and that is submitted. Job submitted is running, and it is being completed. So I'm going to save that all everything model save as. So it is, I'm going to save that as chapter 3, chapter 3 problem 3.2 CAE. So it is being saved in here, you can see. So chapter 3 problem 3.2 CAE file is being saved. Okay, so one analysis done. Now the next step is you need to visualize results. So I'll go here, results, and you can see that problem 3.2 ODB is being there. So that is the deformed shape of that. This one is deformed shape, and here in the plot options, visualization in, or otherwise once you have results in output database like as close. If I go into the visualization, so you don't have anything, so I need to file open ODB. So that is 3.2 ODB, and now then it start working. So here are the plot option. You can go to the label, show node labels, apply, and you can see that these are the node labels there. Okay, this is the deformed part, and then this is the deformed with, this is undeformed, and that is the deformed part. So you then then finally, if you want to get any data from there, so you can go to report, and then you can get field output. So in the visualization, I'll go report, field output, and then here you'll have for unique nodal. So you can get that concentrated force 2, then any movement, then any reaction force, then any reaction moment, and then you can have displacements, stresses, and then so you have selected few. So you can select of your own choice, and I'll go sub here in the setup, and I'll name that report as problem problem 3.2, and I'll apply. So in your work directory, like as here chapter 3 folder, you can see that problem 3.2 report has been created. So that is the report for all your, so you have a concentrated force at node 2, then the action forces are at node 1 and node 4. Then you have some displacements. So at node 1, you have restricted U2, so it is almost 0. Then UR3 is non-zero. So this is how you can create a report. And then you can visualize or you can perform other stuff there. So this is all about modeling, analysis, and visualization of results. Similarly, you can in the contour plots, you can create. I hope this video is useful for you. Thank you very much for watching. So you can leave comments for feedback. Goodbye.